Alright guys, we're back at it here. Um, Laser printer. Let's do this. Alright. Do you all concur? Do you agree? Alright, everything's working up to here. So basically, while run programs equals true is inside the void loop. We didn't get rid of this overall main program loop because if we ever want to toss this program back into dev C++ and go with int main version, we don't have to change that or add it back in. So it doesn't hurt to have a loop inside a loop. They're both just the main while loop though. And we never exit this loop anyways, so it doesn't hurt to have that in this loop. Just do basic blank is just for debugging. This is set to false. It's going to come in here, check for 5-volt signal coming from the solenoid. Does a read-in state on solenoid, which is going to come into pin 4. We have nothing plugged into that rail. It's all clear for pin 4 on the Attiny85. So the Attiny85 will read back that it's off, which is what we want. So it will come into here and it will say if the 5-volt signal's on, turn on LED pin 1 and LED pin 3 for 1 second counts. It's not doing that because it was off. So it actually goes to 5-volt signal is off or 0. And so it does the 5-second blink, which you're seeing in the bottom right, the 5-second blink working. And we had the loop end here, but I just uncommented out the rest. So now we'll add in the rest. Were the signal to go high, it would then come down here and it would run the motor. So if the pickup solenoid kicks on, the motor is going to kick on. And that's where we're at. So I just want to get all the code working without any comments here. So let's just read through it, make sure everything looks okay. There's all kinds of testing and additional breadboarding stuff we can do. Alright, so if we get to this run the motor thing, it will say to run the motor for 1600 milliseconds or 1.6 seconds. Pulse off pickup roller assist motor countdown, so it's going to switch it on and count down to switch it off. Is pickup roller power assist motor pulse on time. So it will stay on until the countdown tells it to turn off. And I have that set at like 100 ms, or 100, which is 100 milliseconds, which is a tenth of a second. So it will turn it on and then off, on, off really fast. As opposed to just turning it on full speed, we want it to run a little slower, because it's a very fast motor. At least in theory. I might want it at full speed, we'll see. Switch on power, pickup roller power assist motor equals true. So it's going to switch it on. Digital write, pickup roller power assist motor, MOSFET PWM pin 0. Okay. Motors on pin 0. And we'll switch it on. Okay. Switch on completed. Check if it's time to pulse off the motor yet. So it will just keep checking. It's time to pulse off equals false. It's time to pulse off equals true. So if the countdown hits 0, it will say it's time to switch it off. And if it's time to switch it off equals true, turn on countdown gets set up, and switch off equals true. If it's time to switch off equals false, check if it's time to switch off, it'll just keep trying to check. Switch off goes down, switches it off. Okay, check if it's time to turn on. Check if it's time to turn on. If the countdown to turn on is 0, then it says it should turn on. And if it should turn on, it will tell it to turn on and set the turn off countdown. If it's not time to turn on, it will just keep spam checking. Is it time to turn on yet? Wait. Never mind. It will keep spamming that, but first it's also going to check while it's off. Are we done with the full sequence? So it will check on the full sequence countdown if that 1600 hit 0 or not. And then if it's fully done, run motor sequence completed. If it's not, it will then check to turn on. Run motor sequence is completed, then it will turn off the motor. It will chill for a little while. I think it could chill for a full second. And then it will check again. And that's it. Then we got our countdown since over. So, uncommenting that, my theory would be that all the code will do the exact same thing because the high signal is not turned on right now. So it should still come into the 5-second blinking because it's not getting the high signal. So let's go ahead and run it. Should work. Let's try it. Well, wait, no. We always want to change it. We'll switch this to 5000 and this to 1000, so it'll blink faster. That way we know something happened and it's still going to this part of the code. Okay, so let's click upload. Haha! You see the light change speeds, and now it's 1 second counts. So it worked. We got all of our code uncommented now. And it's all working. I guess we could test now what would happen if we sent a high signal to that pin 4. And that means 5 volts needs to be fed into pin 4. We can do that. So this blue wire here, if I connect it to 5 volts, okay, which is here. Alright, now that's coming through here, and it's ending right here. This is now 5 volts. And it's going through the proper high ohm resistor or whatever. I can connect that up to this thing. It's going through the resistor, so it shouldn't be a high amp. And it's only 5 volts, which is safe. It's coming directly from the same microcontroller, so it should be fine. That should cause this thing to blink for a 5-second count, as per right here. And then it should do the power assist pickup roller sequence. It should also turn on LED pin 1 permanently. It will go through the power pickup roller assistance 1.6 seconds. It will be turning on pin 0, which right now is just wired back up to the Arduino for communication. So I don't think it'll do anything to the Arduino, which is just chilling in standby mode. So nothing will appear to happen, except pin 1 will come on and it will start blinking, or it will blink 1 time slower. And it will do that over and over, actually. So let's go ahead and do that. I feel safe about it. YOLO. Uh-oh. Nothing happened. Oh, okay, we're good. I was on the wrong pin. Alright, now the test's going to go through. 5 seconds. And then off. And then LED pin 1 was on. 5 seconds. And off. 5 seconds. Wow, it's working. When does LED 1 get turned off? Oh, it does turn off here. After the motor sequence is done, it turns off for a second. Then it goes back to checking for the signal. Which comes into here and turns back on right away, instantly. 5 seconds, then that's off. Run the motor sequence. Motor sequence is only 1.6 seconds, so it should be off for approximately 2 seconds. Yeah, everything's lining up. It's looking like it's doing everything exactly as we're expecting. Wow. Guys, it's all working perfectly. And check this out. If I unplug this signal wire, move it over, it's going to go back to that 1 second deal. It went back to it. 1 second. Because it's now knowing, hey, we're not getting the signal anymore. So now it's back in here. So I just changed the state where pin 4 is no longer receiving a high signal, and now it's reacting accordingly. So it's coming back into, we're not getting the 5-volt signal coming from the solenoid. And it's doing this again. So it's working! Oh man, all the code's working. This is beautiful. I had so many problems, so many growing pains getting things off the ground. But now everything's just going smooth because we got rid of all the kinks. We figured out all the things that were throwing off everything. And now it's all just smooth sailing from here. So, wow. What else do we want to test? I think it'd be pretty cool to actually make the motor move, because it's trying to. It's spam turning on and off the motor right here. Digital right, motor pin 1, or motor pin 0, turn on. It's turning that thing on and off. It's spamming on, off, on, off, on, off for 1600 milliseconds. On, off, on, off, on, off, on, off, really quick. That's called pulse width modulation. Now, you don't want to run it directly to the motor. You want to run it to a MOSFET, which then switches on the motor's power supply, which is supposed to come from elsewhere. What we could do, though, is we could use the MOSFET to switch on and off a light. No, I should actually turn on and off the motor itself. Yeah, I'd rather just actually turn on and off the actual motor itself. We could pull that off. It's gonna be a pain in the butt, but I think it's worth it. I want to see this motor actually turn. I want to see it. I think that's something important to demonstrate. Because otherwise, it's not over till the fat lady sings. We all know these are firsts for everything for me. First time. So nothing can be assumed. I assumed so much stuff would work, and I was wrong about it. So, you know, these are the growing pains of being inexperienced. I'm very inexperienced. I have the knowledge, but lack the practical hands-on. Now I'm getting the practical hands-on for the first time. So really, I have to not assume, oh, I'm just going to, like, everything looks good with the code, I'm just going to put it in, because then once I disconnect it all from this test circuit, I'm screwed if something isn't working. I'd rather test every aspect, down to even the motor itself, before we start connecting everything up to the printer, and then we'd have to pull it all off the printer and get this whole circuit set up again to run our tests if anything went wrong. I'd rather see it all live right here. So that's our next job. And I'm going to create a to-do list for that. So we got to break it down, otherwise it's too overwhelming. Or, no, I like to-do lists. I think it's better. So let me just do that. Otherwise I'm wasting time figuring out what I need to do. Okay. Make LED pin 1 do what pin 3 is doing now, and be our flasher indicating what is going on, and that the white press return. Main while loop is in fact running. Press return. Press return. Make LED. pin 3, comma, which is currently flashing our LED, comma, instead be the, press return, motor turner pin. Press T. Press I. That will PWM the motor through a power MOSFET. Press return. Press return. Encode, comma. Encode, comma. Press return. Press return. Generally get rid of encode, comma. The variable that is currently flashing our LED on pin 3. Press return. Get out IRF3205 MOSFET. Which is 55 volts, comma, 110 amps, comma, 5 volts on. Press return. Press return. Get out 10k ohm resistor to go with the IRF3205 MOSFET. Press return. Press return. Laser printer steps to go. Wire pin 3 use white quick connect fitting to clip to 24 volt power and ground lines. Press return. Coming from laser printer. And run extension wire from that quick connect over to me. Press return. And then attach another quick connect, and then attach that to jumper wires. Press return. And stick those jumper wires into the breadboard. Get a few 10 UF capacitors from one of the circuit boards on the shelf by my air conditioner. Press semicolon. Put away breadboard power supply board. Back into parts bag. Press G. And span between these with a 10 UF capacitor. Press semicolon. Get a 7805 5-volt regulator. Press delete. Press V. Backspace. Press V. Get 100 NF capacitor, aka 0.1 UF. Press F. Ceramic. And run the positive into the left pin of a 7805 regulator. And run the negative into the center pin of a 7805 regulator. Press semicolon. And run the 5-volt regulated line coming off the right pin of the 7805 regulator. And now, send, press return. The 5-volt line and ground through the ceramic capacitor. Press semicolon. Now connect the red line. Press return. $5 to the center pin of our MOSFET. and connect the right pin of our MOSFET to the motor. Press return. Press return. Press return. Solder jumper wire to the mini motor so that we can connect it to our breadboard. Press semicolon. Now connect the ground of the Attiny85. Press delete. To the rightmost pin of the MOSFET. Press return. Press semicolon. Connect pin 3 of the microcontroller to the leftmost pin of the MOSFET. Press return. Press semicolon. Connect the leftmost pin and rightmost pin of the MOSFET together with a 10k ohm resistor. Press return. Press semicolon. Set a electrolytic. 2. Bridging the 2 pins of the motor. Press return. Press return. Get a 1N4004 diode. Floof, you're just in time to see me do real robotics. It's happening. Skynet is being born, and I have no viewers here enjoying it with me. You guys cry all the time that I never work on anything technology related, but here I am, banging out the code, banging out the actual electronics, and nobody's here to celebrate. Oh, man, my right shoulder's bothering me right now. I'm making so much progress, everything's going great. Why is my right shoulder just killing me right now of all times? It's fine when I'm doing my workouts, it's fine when I'm working on everything but robotics, but now that I finally am getting worked on robot stuff, now it wants to be all like, oh, I can't function, oh. So you know what, screw this. I'm just gonna put everything away, I'm gonna sit up, I'm gonna thoroughly massage my shoulder. I'm gonna reset, and then we'll go from there. Because I'm not gonna deal with this throbbing, aching situation. It's really annoying. Alright, we officially removed all mention of LED pin 1. Which is right here. And we made LED pin 1 be on here. Solenoid read-in pin 4 is still fine. LED pin 1 is as the main while loop. Blinker is fine. The motor now will be on pin 3. We use pin 3 and 4 for the motor and the solenoid signal read-in pins because they're the only pins that aren't being affected already by being the communications pins where we actually are able to get our programs from the Arduino. So that's why we use those pins as our two, as one is our input pin, one is our output pin. And we only need really 2 pins for this project. One is input, one is output. All the other pins we're using for communications. We also needed a pin formerly to flash our LED, which will tell us what's going on. That's the only way we can communicate with the code, since we don't have the ability to console out to our computer monitor. We have no way to know what's going on in the code without a flashing light that flashes at strategic times and for strategic amounts of time as a way of talking to us, like what's going on, where in the code are you right now. And so I'm using a flashing light to tell me what's going on in the code visually. Like Morse code, it's like communicating to me intelligently. We don't need a pin for the LED anymore because I discovered that pin 1, if you turn it to high, it actually turns on a built-in light that's on the Attiny85 board. So we're going to use that light for all future LED communications. Okay. So So we did this in code make LED 1 do what pin 3 is doing now and be our flasher, indicating what is going on and that the meanwhile loop is in fact running. Got it. It should have said main while loop. In code make pin 3, which is currently our flashing LED, instead be the motor turner pin that will PWM the motor through a power MOSFET. We did that. Let's just verify. Pin 3 for the motor. Correct. Okay. That was all the code changes we needed. I'm just gonna Control X to copy and delete it all because I want version control. If we make any edits in this IDE, I don't want to try to figure out which IDE had the latest edits, so we're gonna move it all to the Arduino IDE. We'll just move it back and forth. That way we have the latest copy. We don't have to figure out which one we made edits to last or whatever. Version control. Okay. So, let me save this and let's continue. Get out RF 3205 MOSFET, which is 55 volts, 110 amps, 5 volts on. Okay, so we have to get out our part board or our part box and start fetching parts that we will be needing for our continued breadboarding stuff that we have to do. IRF 3205 MOSFET. Where do I have those? "5-volt linear regulator." We're gonna want that too. 65 amp, 200 volts. No. Thermocouple kit. Tip, no, 2N22222A transistor type NPN, 800 milliamps. $40 volts, 5 volts on. Aha! RF 3205 MOSFET. Okay. So we gotta get out one of those. I'll put all my parts here that I'm getting out. Okay. We're gonna need one of these linear regulators. Mailbox, aren't you happy I'm doing electronics? I'm proving to you all that I am the world's greatest roboticist right now. Without question, the greatest. Okay. Do you understand me? Alright. there's our regulator. Alright, so we got this. Got out 10k ohm resistor. Okay, 10k ohm resistors next. It's not a lie! Um, 10k ohm resistor, let's see. No, you're the best roboticist if you have the best skill, knowledge, and plans for robotics. Dang! We're running out of 10k ohm resistors. What the heck? I put these things on everything. We have a 10k ohm resistor crisis on our hands. You know what? I'm buying more 10k ohm resistors. I don't care. This is getting out of hand. $10k ohm resistor. 10k ohm resistor. Press return. 100 of them for 75 cents. Stop listening. They're less than a penny each. And free shipping. That's just awesome. Man, I love yellow people. I think without yellow people, I wouldn't even bother to try to build a robot. It'd just be too expensive. White people are just overpricing everything. Yellow people speak my language on price. $100 pieces. Wake up. 100 pieces. 1/4 watt. 10k ohm resistors. $0.75. Press delete. Press 0. Select all. Press Ctrl C. $0.25. Press Ctrl C. Close window. Press return. Paste it. Press space 5 times. Press space 5 times. Press Ctrl S. Close window. Minimize window. Automod can't target individuals. Alright, we got out the 10k ohm resistor. So that's another one down. Get a few 10 UF electrolytic capacitors from one of the circuit boards on the shelf. Oh, snaps. Now I gotta walk the walk. This means I gotta stand. Dang it. Life is hard. Oh! Okay. I'll need my headlamp. Heat up my soldering station. Okay. Oh, I'm having a hard time getting this one out. Ah! Get wrecked! Got the part, boys. Yeah! I'm gonna get a bunch of them, though. That's one down. What the heck? These 47 UFers should be fine, right? I'm going to desolder these 47 UFers. Got him! That one went much faster. Got him! I think being able to desolder is a valuable skill, so even though the parts are probably really cheap, not all parts are cheap. And I really like the idea of recycling components. It makes it free for anyone. Making robotics free is my thing, man. What could beat free? You know, let's get the fume extractor going. Okay. Got him! We got 4 now. Five, that was a quick one. Six. I'm on a roll. Ha! Get wrecked. Get wrecked. You can see I am improving so quickly. The first one took me forever, and now I'm popping them off in like a couple seconds. Learning I am. Haha! I don't know if I feel like taking a whole lot more off. I got the easiest ones done. Well, let me get this last one over here. Got him. Man, I'm good. Holy cow. What a frickin' genius. What a frickin' electronics mastermind. World's greatest roboticist. What an understatement. We're like galaxy's greatest roboticist. The speed, the intensity. I am to electronics and engineering what Dr. Disrespect is to gaming. I learned from Dr. Disrespect. Look at all these. Free capacitors from my neighbor's trash. They threw away a gold mine. They saw a broken TV, I saw money signs. You throw away your TV, Larry builds a robot from it. That's how that works. Okay. Now, get a few 10 UF electrolytic capacitors from one of the circuit boards on the shelf. Done. Get wrecked. Put away breadboard power supply board back into parts bag. No problemo. Can do. Easy. Boom. Done. That easy. Get 7805 5-volt regulator. Already did. Booyah. Get two 10 NF ceramic capacitors. Okay. I can do that. Uh-oh. We're gonna run out of these quick. I gotta buy some more. I bought the assortment kit, but I only use one type. So let's see. Wake up. $100 ceramic capacitors. Press return. Stop listening. Found it. Here we go. 100-piece bag for 88 cents and free shipping. Under a penny a piece. Booyah! I'll take it. I am a nuisance. I'm always digging through the neighbor's trash. But hey, if they wanted it so bad, why did they put it in the trash? Finders keepers, losers weepers. Their loss is my gain. They're such idiots. 50 volt. Wake up. 50 volt. 100 NF. Ceramic disc capacitors. $0.88. Press delete. Press delete. Press space. Select all. Press Ctrl C. Close window. Press return. Paste it. Press return. Press space 10 times. Press space 20 times. Press space 10 times. Press space 5 times. Press Ctrl S. Close window. Minimize window. Stop listening. Who can have better things to do with their life than build electronics projects? Are you kidding me? They can build a robot that can live their life for them while they lay in bed all day eating Cheetos. What sounds good to you? They could be laying on a beach, sipping martinis, making billions with their robot army, like me, but instead they got better things to do? Alright. So we need to get 2 of these ceramic capacitors, and I just bought 100 more. Because I'm all about stocking up, you know. If we see the inventory getting low, we buy more, period. I mean business. I'm in it to win it. Alright, 2 capacitors, check. I like to get all my parts out at the beginning, then put my part boxes away and stuff, and just have everything ready. Get A1N4004 diode. Okay, where's that? I gotta put away my capacitors. Oh. Cool, I didn't know I bought 10 UF 16 volt SMD ceramic capacitors, or SMD electrolytic capacitors. How cute. They're little baby things. I don't even remember everything I buy, because I'm buying stuff all the time that I think I'll need. Okay, why did I take that? I don't need that. I need a diode. It's funny, I found this board and I took every single part off it, and I've been actually using these parts like crazy. I was just going full hoarder mode and it turned out. Alright. Stop listening. So we have our diode now, that's nice. That thing will work too. See, it's a great size. It's comparable to this. One amp, 100 volt. Wake up. 1 amp, 100 volt. Press 1. 50 volt. Open parentheses. Press 1. Close parentheses. Select all. Press hyphen. Press hyphen. Press hyphen. Press Ctrl S. Stop listening. Stop listening. I got just the video for you, Spectre Dave. Wake up. Robert Murray Smith. Shop heating. paint, electric, Murray. Press return. I think I have a connector that will connect to this little mini motor. It's called a spade connector, female spade connector. If you get a small enough one, it should go right on. I mean, I could just solder to it, but I'm trying to learn to not solder everything all the time. Wow. I don't know, man. I don't know if we have anything small enough for this little motor. What do you mean, Resident Sleeper? I'm doing robotics, literally. That's what you guys dream of. Every time I do anything else, you complain. What do you mean, Resident Sleeper? I'm doing the stuff that is my claim to fame. I'm being the world's leading roboticist right now. You should be so happy. I'm living up to all the hype. All the bragging. Now I'm walking the walk. I don't just talk the talk, I walk the walk. Dang it. Need even smaller spade connectors, I knew it. Well, we'll just have to solder to it then. No choice at all. That's okay. I can't be scared to solder. Well, that was all waste. But, oh well. Solder jumper wire to MIDI motor. Ooh, you know, I'm gonna do something fancy here. Not this thing again. I need it though. Gotta go back in my bag again. I need one of these little boards. Or do I? Yeah, I think I do. Which one, though? Maybe this one. Yeah. That's pretty gangsta. You guys are gonna love this. I'm gonna use this little SMD to dip adapter board. I'm gonna snap one off. There's a whole bunch of them in this kit. This was literally 75 cents, by the way, from China on eBay. But I'm not going to be using SMD on it I'm going to be using it for normal dip, but just using it to do what I need to do. Let's see. We should just be able to snap it off easily. Oh, look at that. That was way too easy. Okay. And then let's see. Straightening out the pins on this diode here. Okay. And I think I can pop these. Oh, wait, I want to put it like this. What would happen if I did that? Bad stuff. Okay, I want it like this. Look at that. So what we can do then is put a little solder bridge between these two pads here and here, and then plug in our wire there, and then another jumper wire there and there. And in doing that, we're able to add components easily to wire, I guess. Is it easy? I mean, it depends if I can get the wire in next to this. No, wait. Yeah, wait. Yeah, I could solder the wire directly onto the component leg. My gosh. Alright. What I'm saying is, I can solder the wire onto that little arm. Just wrap it onto that arm and solder it. And wrap it onto that arm and solder it. As opposed to sticking the wire through the through hole. I just wrap it around the leg of the part. And then solder it and we'll be good. And then we'll have wire coming off in this direction. So the wire is going to wrap around that leg, and then because there's a trace leading to these little pads here and here, we just can create a solder bridge between these two traces, or these two pads, and so the trace will take the component leg to the pad, then we solder bridge the pad, and then it will continue to here. We can put another component in there. And so in that way we can put in our diode and our capacitor across the wires coming off the motor. And that looks like this on the diagram. So here's our motor right here. And then we needed to add a ceramic capacitor here, 0.1 UF ceramic capacitor, and we needed to add a diode here. And so I'm using a little board to set up this little stuff, and I'm going to put that board directly on the motor. Like this. This little board I can mount it right onto the motor, like that. And I have some mounting tape I can do it with too. We'll just put it right on here. Boom. That easy. We don't even have to use hot glue. I have this really good tape that they use for GoPros to mount GoPro cameras to helmets for sporting enthusiasts. And I bought that special GoPro style tape. It lasts 10 years on my whitewater kayaking helmet. This stuff never comes off. It's a foam tape. So I'd be able to stick this, it's a double stick tape, stick this thing right on the tape, and then just stick it on the motor. It'll never come off. But it can come off without any residue. But it just won't unless if you use like a pry bar. And that's good. It'll be nice and strong for us. And we can cut this board in half and save the other half we're not needing. We just need 4 pins of it. So that's the plan. And it's a brilliant plan, boys. That as opposed to doing what I did here, which was fine, but it took a lot more work. Being able to cut out proto board, and then the components are 4 pins across. And I had to meticulously score it, and then break it apart and use a vacuum to sand the sharp edges of the proto board. And it's just a lot more labor intensive to be able to put components into proto board. It's going to be so much easier just to use this SMD board, which is already cut out. It's already ready to go in the smaller size. Those are my 2 variations, so I'm learning. I'm getting better tactics here. Or I'm experimenting with different ways to solve the problems. Or not the problem. I guess you could call it problems. So yeah, I think this is a cool thing we came up with here. Alright, let's get... Well, wait. What is my actual job here? Set a 100 NF capacitor, aka 0.1 bridging the 2 pins of the motor. Okay. Set a 1N004 diode bridging the 2 pins of the motor. Okay. Alright, I just put the capacitor on too. So now we got the diode and the capacitor in place. Onto double stick tape. And wrap it across. Press return. Press return. The top of the mini motor. Well, shoot, it looks like we still got time. I feel like quitting for the day, but I could do a little bit more. Put one for the team, right? I mean, I love what I'm doing. This is neat stuff. I'm so excited. I have all the knowledge. I'm coming up with my own techniques for doing stuff. It's all good stuff. It's just, sucks that I always gotta work on electronics day, like, when I'm half asleep at the end of my day. Never have energy to do a whole lot, or time to do a whole lot. I already had my workout today and done a million other things. That's frustrating. Oh, wow. I might use these pre-cut wires. They're ready to go. Oh my gosh. That's awesome. Yeah, I bought this pack of breadboard jumper wires. It's a assortment of them. They're pre-cut and everything ready to go. And I thought they'd be just for breadboard, but I'm going to use them for debugging stuff too. It's so much faster if you can not have to cut and strip wires. That's a huge, believe me, a huge. That's like 90% of the time I spend with electronics is cutting and stripping wires. So between using jumper wires that are long, flexible, and just plugging it into jumper pin or to the breadboard, that has been a huge time saver for quickly prototyping. And then if I can use these pre-cut and tinned wires for the actual solder wire stuff, dead bug stuff, that will be another huge time saver. So I'm very excited about this. Okay. Okay. Yeah. Uh-oh. Okay. Alright. Alright, so we have basically created a 1000 denier nylon strap, which will be taped on with this powerful double stick tape to our motor, and then the motor will be locked by that, and then we got enough tape left as flaps on the side to tape it onto the printer as well, so this motor ain't going anywhere. And it's a connection purely based on tape, and yeah, no screws required or anything. No pulling out a lathe and fabricating some kind of clamping system. None of that needed. Okay. Alright, so I just cut the tape where I want the flanges done and where I want the motor to be attached, or the flanges to start. So we're keeping the wax backing on the double stick tape everywhere that the motor's not at. And I believe that'll do it. Haha! Get wrecked, son. There we have it. So this tape will go on the printer, and our motor will be mounted. Just like that. In fact, for extra strength on this part of the printer, or the motor, we can put some of this GoPro mounting tape. Then it'll really be on there good. Okay. So we got kind of overkill. Well, no, I don't think it's overkill. It's a motor after all. I mean, it's got to be down on there good. We got 2 types of tape ready to go. So we got flanges down and we got the foam mounting tape down. That'll be plenty. So it's going to work great. If we want additional, we can put a piece of this fabric tape down on the printer and then sew that into this motor with like a strapping down system, a bunch of upholstery threads sewing it down tighter and tighter. Kind of like many little strings tied down Gulliver and Gulliver's Travels. The little people, just these tiny little strings, if there's enough of them, you can generate a tremendous amount of tensile strength. So there's that. Wow. Okay, so I get to cross that off. This thing's ready for mounting, so now we can begin attaching electronics to it freely. I had to do that first. But that's a perfect place to end because actually we are out of time. But I tell you what, man, what a excellent progress day, though. This thing's happening, man. It's going down. It's all going down, man. We're getting there. This is great. Great progress day. Huge progress. It's happening, man. This printer's gonna be fixed in no time. It's so exciting, too. I mean, there's still a lot of steps, don't get me wrong, but it's just coming together really nice. And this is going to be my first major electronics project involving microcontrollers and stuff. And motors. In fact, with this setup, we're pretty much, like, we could have had the robot's finger move if we put this much effort into that. But I just decided, you know what, I'm not going to get the robot's finger to move based on what? A battery that I need to manually recharge? Like, a power supply system has to come first. It has to have a setup where it's able to get power. I have to create that first. So that's why the robot moving is so delayed. Whereas with this project, I'm tapping into the printer's power supply. So that sped me up a lot. Having that in place, everything else just flows out of that. So anyways, everything's coming along great here. And it's going to be getting done before you know it. So anyways, guys, have a good day or night.